Now let us go to question number 8 in the question paper. Question asks this: aniline on nitration gives 47% meta-nitroaniline. Give a reason for this. That is the question. That is only purely a descriptive question. There is no need of any structures to be written there. Normally, aniline, as you know, is an extraordinarily activating group. When it is directly attached to the benzene ring, we are giving an answer for this question number 8, which says that aniline on nitration gives 47% meta-nitroaniline. This aniline generally is basic. The amino group is nucleophilic. On account of that, it activates the nucleus. So, in an electrolytic substitution, it should be activated. But this nitration experiment has to be carried out only under strongly acid conditions. Normally, the nitratic mixture, as we all know, is a mixture of nitric acid and sulfuric acid. This amino group being basic group, this gets protonated and it is no longer nucleophilic. This becomes NH3 plus. The moment it becomes the NH3 plus, we are giving answers for the question number 8. And now we are making that aniline, which was previously nucleophilic NH2, as NH3 plus, which is going to be electron deficient or electrophilic. Therefore, any electrophilic group that is attached to the benzene ring is meta-orienting. Therefore, on nitration, this gives a fairly sizable amount, as it is given there, a good amount of the meta-nitroaniline as the product. That is actually the answer for question number 8. Because NH2 is being made as NH3 plus, it gives rise to a meta product because it is a meta orienting group. Now coming to question number 9, how is a mixture of primary, secondary and tertiary amines separated? That is question number 9. Refer to question number 9 in that series. This is effected by means of a reagent which is known as Hinsberg reagent. Hinsberg method, or this is known as a Hinsberg reagent. What is meant by this Hinsberg reagent? Hinsberg reagent is just nothing but para-toluene sulfonyl chloride, or sometimes even benzene sulfonyl chloride. This we will take it as para-toluene sulfonyl chloride. This para-toluene sulfonyl chloride reacts with amines. Supposing it reacts with the primary amine, this will lead to the formation of a para-toluene benzene sulfonamide. This will lead to the formation of C6H5, this paramethyl with NH with this aniline. Assume it reacts with aniline. So this is the derivative that is obtained. This is known as para-toluene sulfonamide of aniline. Now, this para-toluene sulfonamide of aniline, this nitrogen contains the hydrogen. Therefore, this product obtained when it is treated with potassium hydroxide will dissolve immediately. In other words, a primary amine on reaction with the Hinsberg reagent will give it a sulfonamide derivative which is soluble in potassium hydroxide. Then in that case, it is a primary amine. In the case of the secondary amine, there is no hydrogen here. There will be another alkyl group. Therefore, up to this point, it is the same. You treat a secondary amine with Hinsberg reagent, it will give rise to an amide, but that amide is not going to be NH. This is going to be something like another group which is known as NR. Therefore, when it is dissolved, when you want to dissolve it in potassium hydroxide, it will not be soluble in potassium hydroxide. This will be insoluble in potassium hydroxide. Just to repeat it, this benzene sulfonyl chloride on treatment with the secondary amine will give a sulfonamide which is not soluble in potassium hydroxide, means it is a secondary amine. A tertiary amine will not react with this benzene sulfonamide, benzene sulfonyl chloride to give a benzene sulfonamide, and therefore there will not be any reaction. Then in that case, it will be a tertiary amine. This is how this is used to separate the primary, secondary and tertiary amine.